I'm going to show you how to give your AI access to thousands of private documents it's never seen before and then still be able to cite the exact paragraph it pulled the answer from. So in the next 10 minutes, you're going to build your very own production grade RAG system. No fine tuning and no sending your data anywhere that it shouldn't go. To preface, anytime a model gets a longer context window or fine tuning gets a little easier, someone says that you don't need retrieval anymore. But here's what happens in actual companies. Data is sensitive, volatile, and fast. Additionally, computation is at a premium for most companies, so fine tuning always isn't an option. Luckily, we can solve all of these issues with RAG, Retrieval Augmented Generation. It's private data, fast-moving data, data you need to cite. And in any of these scenarios, RAG is a good bet. And this is no pet project, because the moment you wire retrieval into an agent loop, it becomes a tool that the model decides when to call. This is what we call Agentic RAG, and it's the backbone of basically every serious AI project right now. For example, augmenting your cloud queries with web searches is essentially just Agentic RAG. So in the next 10 minutes, you're gonna learn how to build your very own RAG, and it's only 3 moving parts. First, a Next.js web page to upload text, PDFs, and a URL. Secondly, a Supabase backend that chunks, embeds, and stores everything as vectors. And then thirdly, a question and answer loop that pulls the right context and then asks Gemini to answer with sources. And just quickly, some theory to recap, a RAG is only 2 phases. Firstly, a write phase where we slice your documents up, turn each slice into a vector, and then store it. Secondly, a read phase where we turn the question into a vector as well, find the slices that are closest to it, and then hand those to the model as context. I build these in production all the time for various different companies, so I'll also leave you with some tips if you want to scale this up in the future. The prompt I use along with the code for this exact implementation are all in the description below. So let's dive in. Okay, to get started with this build, I've included a guide below. It's in the description. If you'd like to follow along without this video and or build a RAG that's a little bit more complex that has some of those production considerations I was talking about in the beginning, feel free to go through this guide. It's completely free. It's a free URL. The blueprint is below. The link is below in the description. Feel free to go through it if you want to. You could take this, for example, this entire guide, throw it into an AI agent and tell it to just build the entire thing for you and it should be fine. But before we get started, the first thing we want to do is create a new project on Supabase. So I'm just going to call this RAG tutorial. I mean, you can call it whatever you want. The password isn't super useful for us right now because we're going to have our AI agent connect to the database anyways and using a key. So we're going to enable automatic RLS. This is just so that no application has access to rows and tables that it shouldn't have access to. So the access pattern is locked down to only whatever is necessary. You can go ahead and configure that. It takes a few minutes to configure and set up the entire Supabase project. So I'm going to go ahead and kick that off. And in the meantime, I'll talk a little bit about the prompt. So to build this, I use the prompt to have an AI agent. I'm using Claude to build the entire thing for me. But the most important things with the prompt is obviously to make sure you're informing the AI agent exactly what you want. You don't have to be super specific. You just have to make sure you're pointing in the right direction. So for this build, I'm saying I want to build a RAG system and I want to chunk the text that I upload into the front-end application that I'm building, and it should accept PDFs, it should accept text files, it should accept markdown files, and it'll chunk it and then send it to an edge function on Supabase. And then that edge function will process it using Gemini, and then Gemini will, after the chunks have been created, it'll store it into the database. And then anytime I wanted to retrieve that information, it'll go to the database on Supabase and then pull the retrieved chunks and then make predictions accordingly. So you can jump into Cloud Code and then paste it in, and then you'll get a repo that looks similar to mine. But obviously, because AI agents are non-deterministic, you may end up with a repo that's slightly different. So you can never really be sure that you'll have the right thing. So to that end, I've included the repo as well if you wanted to take this and then paste it into your AI or clone that repo and then ask your AI agent, hey, take a look at this repo, modify it accordingly. Feel free to do that. A couple of things I want to dive into really quickly before we get everything set up. The first thing are the Supabase functions. Remember how I mentioned the edge function that you would have to actually do the chunks? This is where that lives. So there's 2 edge functions we'll be deploying. One is called ingest and one is called query. The ingest one is obviously to take the data in and then chunk it and then store it into the database. The query one is upon inference, anytime you want to find data or anytime the AI agent needs to find data to reference inside of the database and then pull it into its context window so that it can make downstream predictions or downstream references, it uses query. So we're going to be deploying 2 edge functions, and I'll show you exactly how to do that. It's pretty simple. The next one here is migrations. This is just setting up the database for us and telling Supabase, hey, this database is meant to store chunks of text. Go ahead and store those chunks of text and then make sure there's the capability to store it as vectors. And we're going to be using 768 as the dimension for the vector. This is a common dimension for vectors that are representative of sentences. That's sentence embedding, kind of theory is a whole field of its own. We can use 768. It seems to be a pretty good, nice number that works well with the inner dimensions of the transformer model that is used to actually create those embeddings downstream. So 768 here is the one that you need to focus on, but for the most part, this entire schema is set up in order for you to be successful. So, okay, so let's take a look at our Supabase here. It's still loading up, so I'll be back in just a short moment once that's done. So the next thing we're going to do is go to Google's AI Studio to get a Gemini API key. Now, I'm going to show you this video or this build without using Gemini's API because Supabase actually has a built-in way of generating embeddings for you. But if you want a more accurate representation of your sentences, use Gemini's model instead. It's basically almost free. You do have to sign up for an account and then put in your payment details because it does still cost you money. So if you want the free solution that's wrapped in with Supabase, go for the one that I'm going to show you during this build. But just so you know, if you do want to mix it or change it to Google's AI Studio or using their Gemini's embedding model, you can do it using the guide that I've included here. All you'll need is a Google AI Studio or Gemini API key, and you can do that by going to Google's AI Studio and then clicking this Get API key here, and then it'll walk you through all the instructions. I have one set up that I used for this build, but you can set one up if you want to change this from Supabase's generate embeddings to Gemini's. And you can see I'll include this link as well in the description if you'd like to learn a little bit more about the accuracy of Supabase's embeddings. It's using Hugging Face under the hood to be honest. So you'll see this one here, it's gte-small. So if you want to learn a little bit more about this, it's Supabase's model, but it's hosted on Hugging Face, which is nice. So it is quite compatible, and you'll see its performance here, and you can switch to GT. I think only gte-small is supported on the Edge functions because obviously Edge functions are very small slices of code. So the next thing we're going to do is log into Supabase using the CLI. Now, everything that I'm showing you here, you could actually do on the Supabase panel. However, I feel that it's a little bit better to use the CLI because you can replicate all of the steps that you needed to do this build and then just run it as a script if you ever need to do this again or pass it off to someone else. So I'm going to do that here, but you're more than welcome to do everything through the Supabase panel if you'd like to. So once you type in Supabase login into a terminal, it'll give you the option to log in here. Then it'll give you a code. I'll copy the code and then paste it in back into the terminal. And I'm good to go here. So I can close this. And then the next step is super simple. All we're going to do is link the project here. So the command to do that is Supabase, and don't worry, all the commands will be inside of the description below. Project ref, and then the URL that we just copied. We're going to go ahead and paste that in. Sorry, I made a mistake. It's just this project ID here. So Supabase link, project ref, and then just the ID itself. You don't need to be redundant with the URL because it knows where to find that URL after you give it the ID. Okay, the next thing we're going to do before we actually go ahead and finish up our build here, I know we're almost at the end, is Supabase DB push. Anytime you create a new migration, you can do Supabase DB push and it'll layer the new migration on top. It'll give you a prompt if you're using Mac. I'm using Mac. It'll give you a prompt to log in just to authenticate that you're kind of giving permissions to your terminal to push up to Supabase. And you can confirm that that worked by going into your table editor here, checking documents, and you'll see that the table is set up for us. The one thing to note here is the embedding is of type vector. This is not a native type that's supported by any traditional relational database management systems or Postgres or whatever. This is a specific field type that Supabase offers in their Postgres solution, which is really nice. You don't have to worry about, spinning up a different type of database that has vector support, like a Pinecone or something. The final thing we have to do to get this set up is deploy our Edge functions. Right now, if you go into the Edge functions portion on the left-hand side here, you'll see there's nothing there. I'll show you really quickly how we can do that without too much effort. So the first thing is that we want to take a look at the two index.ts files. And all we have to do is push them up using a similar command to what we did before. However, if you wanted to copy and paste the code directly within the panel, you're more than welcome to do that as well. This way I find is a little bit easier after you've logged in. You can see here deployed functions now exist on the project. And if you refresh the page, you'll see both of them, ingest and query. And that's great. Everything is good to go now. All we need to do is run our front end and we should be good to go. So the final thing we need to do is actually on the web side, the front end, you'll take a look at the repo and it has an env.local.example. What this means is this is basically an environment variable file. We can copy and paste this file. The reason it has this kind of nomenclature of having .example at the end is because it's meant to be a hidden file that stays only on your computer. .env and .env.local should never be pushed up to any Git repository. And eventually, if you do put this into production and you want to serve it with your colleagues or whatever, or you're building like an application, you wouldn't ever push up at .env.local. So what we do is we type .env.local.example. That example file should not have any sensitive data in it. Actually, GitHub does a really good job of identifying whether or not there are potentially security vulnerable based keys that get pushed up by accident, because this happens all the time. So what we're going to do here is just put in the ref for a Supabase project, similar to how we did before. We're going to go ahead and paste this one in. So we made a new file, .env.local, and this will allow us to run. So we can take a look at the package.json, and we can see that Next.dev will allow us to build this locally. And that's exactly what we're going to do. We're going to change it to web, and we can test to make sure this works locally first before actually pushing it up. The tutorial ends when we actually get this locally running, because the pushing up of a web project is quite simple. I can cover that in another video, but it doesn't really have anything to do with RAG. So we can end here once we get this running. So the first thing we want to do here is just do an npm install really quickly to get this to work. This will install all of the local dependencies for our web application. You'll see a node modules folder pop up here. This node module folder holds all of the dependencies we need in order to get this to run. We'll do npm run dev. And give it a moment. Just like that, we have localhost 3000 pop up. We can go ahead and open this. Very simple web page. You can either paste text from a URL or a PDF. I've gone ahead and downloaded this PDF already, but I think it's probably just faster if I copy and paste it. This is the Attention is All You Need paper, one of my favorite research papers of all time. So I've just copied the first portion of it. And then I can come in here, paste it in, and you can click ingest text. You'll actually see there's no documents that exist here yet in the database. But once this is done, stored 8 chunks from the pasted text. If you refresh this, you'll see in the database that it all exists here. You can even see the embedding, which is quite cool. You can see what the embedding looks like. Sorry, actually, I think the viewer here is kind of weird, but you can see what the embedding looks like, and you can see what the text looks like. And this is how it was able to chunk it. And it's chunking out in character here, and you can see that because it doesn't actually finish the word, which is cool. You can change your chunking strategy if you want to, but if you know a little bit about RAG. And you can see here, I can ask it what is the transformer, press enter, and it'll come back with a response for me in just a moment, hopefully. Great, and you'll see here it was able to reference all of the chunks, and it even gives you the accuracy for each chunk. Now, obviously this is a very simple web page. It doesn't really have too much going on. Your next steps would be deploying this if you wanted to, and making it look and work a lot faster and nicer. Now, one caveat that I didn't get a chance to mention is these secrets here. So just make sure you're setting these secrets accordingly. You have project URL, service role key, and Gemini API key. I'll delete this project after, so these keys will not be valid anymore. But for the most part, you're able to add these keys, and your functions need to know about the key's existence. For example, the Gemini API key, I use it for the AI agent here. By default, the Supabase doesn't have an AI agent built in, so it can't respond to you with an LLMs-based response. I think they do offer a small one, but it's not really coherent, at least in my opinion. So I'm using Gemini here for crafting the responses, and then obviously using the Supabase embedding model for doing the chunking. So all of that working together, lots of different moving parts, but finally we've been able to build something like this. The next steps would be to deploy this up on the web, and then make sure you have, like, you can deploy it to GitHub or push it up to GitHub and then deploy it to Vercel, which is the stack that I usually use for small projects, and it works perfectly. And there you have it, your very own RAG system. And that's the entire build. The repo and the prompt are both linked below. You can clone it, paste your keys, and then deploy. About 10 minutes end to end if your accounts are already set up. But here's the thing I want to leave you with. When you build this way, the value isn't that you type less code. It's that you spent your time on the decisions only you can make in the beginning. The stack, the spec, the secrets, the production posture, all of it. That is the part that actually matters here, because an AI agent now can just build the entire thing for you. So here's the real question. What's the first data set you'd point this at? Your company docs, your Notion, your inbox? Personally, I'm using this with Notion a lot so that Claude can reference all of my Notion documents and then make predictions. I make builds like this all the time, so if this one was helpful, drop a like and subscribe so you don't miss the next one. See ya.